Hello, this is Dr. Lori. Now that we have run the odds ratio and the chi-square tests with SPSS, I'd like to review a little bit how the hypothesis testing process would work with these. First of all, let's go over the odds ratio. And here are the numbers down here at the bottom. This top row is what we're looking at, the odds ratio for exposure, exposed versus not exposed. And the actual odds ratio calculated number is 234.333. You can double check that against what we calculated it to be. And then the nice thing about having SPSS calculate this for us is that it also calculates a 95% confidence interval around that estimate. And so this gives us an idea of how sure we are that that number is or is not equal to the null value of the odds ratio. So let's start at the beginning of the null hypothesis testing process, which is to state the null and alternative hypotheses. So the null hypothesis really is that we see no relationship, or there's no relationship between, and in this case, there's no relationship between DES, diethylstilbestrol, and vaginal clear cell adenocarcinoma among these study participants. And so if there is no relationship, then knowing something about the exposure doesn't really tell us anything about the outcome. The alternative hypothesis, on the other hand, is that there is a relationship between those two. And specifically, if you wanted to write those null and alternative hypotheses numerically, you could say for the relationship between DES and VCCA, the odds ratio is equal to 1. The alternative would be similar, only the odds ratio is not equal to 1. So remember how an odds ratio equal to 1 means that the odds among the cases is the same as the odds among the controls. So we really don't see any difference in exposure between the two different groups. If the numerator and the denominator of a fraction are the same, then that fraction will equal 1. And so when an odds ratio equals 1, that really is the null value of our odds ratio. In other words, that means that there's nothing interesting, there's nothing to see here, there's no relationship, all of those things. So once we performed the test in SPSS, the odds ratio that we found was 234.333. So that's really the test value, the critical value that we're looking for. And if we were to write the 95% confidence interval, we generally write that with a parentheses. We put the lower number and then a comma, and then we put the upper number and then a parentheses after it. So 22.804, comma, 2407.974 and parentheses. So that's my 95% confidence interval. And the way we interpret that is by comparing that confidence interval to the null value. In other words, how does that confidence interval compare to an odds ratio equal to 1? Well, 1 is very far away from 22. So this confidence interval, another way of saying that is this confidence interval does not include the value of 1. In other words, 1 is not contained in that range. And so based on saying it all those different possible ways, we can conclude that we would reject the null hypothesis. If this confidence interval included 1, let's say it went down to 0.5 and then up to 2400, then that range includes the value 1, then we would fail to reject the null. So I'm giving you the alternative, like what would happen if the results were different. But in this case, we reject the null. And the way we say that in plain English is there is a relationship between DES and VCCA. If we know something about DES, then we know something about the outcome or the disease. And then, of course, based on any conclusion, you would want to be able to think critically about what type of error you could make. And so that is the final question in the hypothesis testing process. Thank you for joining me for this short video.